Okay, so once again, for Thevenin, what we're going to do is, or for Thevenin's theorem, what we're going to do is we're going to solve for the impedance Z Thevenin by shorting all voltage sources and opening any current sources. And then we're effectively going to measure the impedance from the terminals A and B. So what we've done is we're um, breaking the circuit at 2 points, and then we're going to find the impedance over to the left of those, or of the part that we want to find the Z Thevenin for. And then we're going to find the voltage drop with A and B open. We just want to like measure the voltage here and get the voltage drop. Okay. And so that gives us then this Thevenin equivalent circuit where we have E Thevenin at an angle of theta Thevenin. Okay, now chances are this angle is not going to be a zero angle, so make a note of that. But we have E Thevenin and Z Thevenin now in series. So you have your voltage source in series with this Thevenin impedance, and that replaces this more complex circuit. And then now we can apply impedances at terminals A and B, and we can then kind of do studies on that and find out, well, what is the optimal resistance? What is the optimal reactance within that circuit? Okay. And so that's what we're going to do here. They give us this circuit. This is the circuit that they give us. And we have resistor R1, we have resistor R2, and an inductor L of 10 millihenries. And so this is our circuit that we want to find the impedance for. Okay, and then we're going to hook up a voltage source to that with various frequencies. And they give us, to start off with, they give us a 10 kilohertz frequency, but we're going to be modifying that as we go along. Okay, and so this is the lab here that we're going to do today. And here is table 13.1, where we're going to calculate the E Thevenin and Z Thevenin. Okay, so we're going to find out what E Thevenin and Z Thevenin are for this circuit here, breaking at where RL, so we're going to, node A and node B here are where RL is connected. Okay, he didn't actually label those this time, but that's the A and B. And so when you do this table here, E Thevenin is going to be the same for both the original and the Thevenin equivalent. But then what he's going to do is have us determine the load RL, the voltage across the load RL for the original circuit and the Thevenin circuit when RL is equal to 1K. And then we're going to do it again when RL is equal to 6K. All right, and so that's going to fill out this table. Then we're going to talk about maximum power. Okay, so maximum power here is when the load applied at those terminals A and B is the complex conjugate of the Thevenin. Okay, so let me scroll down here. So when we talk about the maximum power, okay, we're skipping part 2 of this lab, by the way, so make a note of that. But all right, so here maximum power occurs when, if you have an inductor and a resistance, which of course we do have here. So you have an inductance and resistance for Z Thevenin. Then what you need to do is you need to find the capacitance that gives the exact same reactance and put that in there. So we use what they call the complex conjugate of that. Okay. And so we're going to put in a capacitor in series with RL. And then we're going to adjust, make adjustments there to get these values. So for various values of capacitance here, we are going to have RL. And adjust RL. So RL is in a potentiometer, so we're going to adjust RL. And we've got our C. And so we're going to find RL and X of L and Z Thevenin, which of course isn't changing, but ZL, which is the load, which is the R plus the capacitive reactance. Okay. And we're going to find the peak voltage. Okay. So we're going to find the peak to peak voltage. Okay. Now notice here, he's saying peak to peak. So he's got VAB is the peak to peak voltage. So remember, if we were in the classroom, we would be using an oscilloscope to measure this. Okay. And so what they're doing here is measuring the peak to peak voltage. And then he's going to calculate power. Okay, now remember, power is I squared R or V squared divided by R. But if you look at this equation here, this equation kind of throws you for a loop. I was looking at this last night and I thought, okay, where is this 8 coming from? I don't remember. And I remember the last time I taught this class and I looked at that and I'm like, I had to sit there and think about where this 8. So notice here they've got V squared divided by 8 times the resistance. Well, where does that come from? Well, he gives you that in this equation right here, equation 13.2. All right, so remember that when you're calculating power, right, we're talking about real power or DC equivalent power. So that is equal to either I squared times R or V squared divided by R. But you got to be using that RMS or that DC equivalent voltage. But what he's asking us to measure is the peak to peak voltage. All right. So when you look at this equation, you remember that peak to peak, to get to a peak, you have to divide by 2. And then to get to RMS, you have to divide by the square root of 2. Well, you square 2 and that gives you 4. You square the square root of 2 and that gives you 2, and 2 times 4 gives you 8. So that's where this number 8 is popping up at, down here in the denominator. Okay, so 8 is down here in the denominator due to the fact that we're converting from a peak to peak voltage to a RMS value, and that's where that 8 comes from. All right. And then once we do that, we need to plot that on the graph. Okay. And then that was part 3. And then part 4, we're kind of going to do the same thing, only this time we're going to adjust RL. Okay. So he gives us the capacitance, but he asks us to adjust RL and then plot how we're going to actually accomplish this. Okay, if we log into Blackboard and go under lesson, we're in week 11 here. Okay, so I'm going to scroll down to week 11, and what I've done is I've uploaded a document file here. All right, so here is this document. It says Lab13, your name here. So I'm going to click on this document and open it with Word. And what I did, okay, in this document, as you're going to see here, we need to click on Enable Editing here. And the first thing we want to do is put our name in here. Okay. And then what I did was that table that we looked at originally, where you have to put in like E Thevenin and Z Thevenin and all that, I put that in here so you can just come in here and, you know, put in that value, whatever it is, you know, 4 volts, angle, 32.7 degrees or whatever. Okay, now remember we need to use our 4 significant digits. Okay, or excuse me, 3 significant digits when we do this. And then if you want, you can just type out degrees here, or you can go look up the symbol if you want. I'll take either one. Okay, but I do want to see the units, the 3 significant digits and stuff, and you just put those here in the table. All right, and then what we're going to do is we're going to open Multisim. So hopefully everybody's got that installed. I know some people were having some trouble, but it seemed like most everybody was able to get it installed who didn't already have it installed. All right, and so we go to Multisim here, and we're going to build our circuit. Okay, so let me just kind of go through here. I'm going to kind of build the circuit. So remember, let's say we need an AC power module or voltage source, basically. We need ground. Be a ground in here somewhere. There it is. Okay, so we need our ground. Okay. And then we need a resistor. Okay. Now I'm not going to build the whole circuit right now. I'm just going to grab in a couple of values here. Thing we want is we want a variable resistor. And because remember, for the at least the one part of the lab, we had to have that variable. I'm going to right click on this and rotate it. All right, and now I'm going to connect these together. Okay, and the way I find this works is, you know, you notice here how I hook the voltage source over to that resistor, and then I'm just going to attach the ground here. So remember, to simulate, you must have that ground somewhere in the circuit. Okay, and then what I'm going to do is I'm going to come up here to simulate, and I'm going to come over to instruments. Or see, no, wait a minute, that's right. I really actually, I think the best way is these probes. This is what I was looking for here. So I'm going to grab a probe. Okay, and what you notice with these probes is they actually show you a voltage peak to peak, a voltage RMS, and so on. And if you double click on that and you come over to parameters, okay, you can get it to show you the phase angle. So we want peak to peak. We're not using DC, so I'm going to turn that off. If you want, you can do peak to peak and RMS. That's fine. You can leave the frequency there if you want. I'm going to shut those off, but I do want to see the gain also. Okay. So here we've got the peak to peak, the RMS, and we have the phase angle. It says frequency there. Okay. And now what I do is once I select and get my what I want to view, whether it's peak to peak or DC or whatever, I like to just copy this probe instead of grabbing another one. All right. And so that way it will, I'm going to just grab all this and slide it down here just a little bit. Come on. There we go. Grab the entire thing so I can get this up a little bit. All right, so when you grab a probe, once you get the probe set to the values you want, it just works better to copy it. Because if you come over and you grab it again, then you got to go back through and deselect things you don't want. All right, so now if I then simulate this, okay, then I get my voltages and I get the frequency. Let's see, it's supposed to be shown in phase there, but it's not. Phase. A gain phase reference probe. So I need to use a gain phase reference probe. Not sure where a gain. Okay, so yeah, so it's like, I mean, it's telling me it's going to show the phase here, but gain, there it is. Okay, gain phase reference probe. Okay, so we got to check that box to get the phase. That's what it's telling us. All right, so again, once you get it selected there, um, oh, so it has to be a reference. I see what it's doing. It's doing a reference to this phase. Okay. Yeah, so, okay, so what we're doing here is we are setting up, you need at least two probes for this to work in this way here to get the phase angle. So you got to have the first probe. So here's, I mean, it's actually labeled probe 2, but this is kind of my reference because it's over at my voltage. And so now this one then I mark as a gain phase reference, and I reference it back to the source one. And so therefore it can actually give me the phase angle. Okay, otherwise it wasn't giving me the phase angle. All right, so then, and this go ahead, I guess I'll throw in the inductor here so that we can at least see some phase shift. Okay, so I'm going to come over to inductor and grab a 10 milli. Okay, and put in here. And so now we should see some phase shift. Now notice here, our voltage source is 120 volts RMS, okay, 60 hertz, and 0 degree is our phase shift. All right, and so we need to change that to match the lab. So if we look at the lab, we look at the circuit in the lab, it was 8 volts peak to peak. Okay, so I'm going to double click on this and I'm going to make this 8 volts. Um, let's see, 8 volts peak to peak. Okay. And let's see, this is 8 volts RMS here. Okay. And so what we have to do is we have to calculate that. Okay. So open up our calculator, and so we have 8 volts peak to peak, right, divided by 2 gives me 4 volts peak, right? And then we're going to divide by the square root of 2, which is 1.414, is 2.829. Okay, so I'm going to put in here 2.829 and RMS. And then I also have the phase angle. I can set the phase angle. So when you determine what E Thevenin is, you're going to have to put in your phase angle. Okay, so you're going to have to come down here and put your phase angle in, however many degrees that is. I just stuck 13 in for now. Okay, and now when we simulate this, okay, we are getting we're getting the voltage, okay, which again is supposed to be 8 volts peak to peak. It's 7.97. That's close enough, right? We're in lab today, right? So it's okay to be a little bit off. 2.83 volts, RMS, 60 hertz, okay? And then here you see your phase angle, okay? So this is the phase angle. Now remember, this is only, this is at 60 hertz. And so the phase angle is 0.173 degrees, okay? So then what you're going to have to do, they told us to go to, what was it, 10 kilohertz. So then we're going to have to just stop the simulation, come in here, change your frequency. You can either just put in 10,000 or put in 10K, should take either one. All right, and then simulate it again, and now you see the phase angle is different. Okay, and so this gives us this simulation here. Now, what I need you to do as part of the lab, if we flip back over to the lab, the document that I gave you, is I want to see this circuit. See here where I highlighted circuit 13.4? So what we need to do is we need to open the snip tool. So do your Windows search and go to snipping tool. Okay, and we're going to, we open the snipping tool. Okay, go back to your program. Okay, and for snipping tool, click, press new, and come over here and highlight just the circuit like this. And then we're going to select copy up here at the top. And then we're going to go over to our Word document, and right here where it's highlighted, I'm just going to paste in that circuit. Okay, so I'm going to paste in that circuit right there. Okay, so is there any questions about how to copy your circuit and paste it in there? Okay, now there was a question whether you use the online version of Multisim or some other online. I don't really care what version of circuit simulation you use, as long as it works and you get the right values, and you can take a snapshot of the circuit and throw in here. I don't really care which version you're using. But I can't really help you with the other ones. Multisim's the only one I really work with. So All right, so anyhow, so I pasted that circuit right in there, right? So we pasted that circuit right here. It says, give me the circuit 13.4. So that was the circuit in the lab, right? Here's the circuit figure 13.4. And so I paste that right in here, okay? So I used that snipping tool and just grabbed the picture of the circuit. Okay, I don't care about the little grid dots on there, that's fine. And then we're going to work through the lab. Okay, this is part one of the lab. So you're going to work through the lab and you're going to find E Thevenin and Z Thevenin. Okay, so you're going to just work through the lab, figure out what those are, and then you're going to, you're supposed to find the original circuit. In the original circuit, and this isn't the original circuit, right? I didn't finish the whole thing. I just threw some values in here. But in the original circuit, you're going to set the load resistor, which is this guy over here, to 1K. And in the original circuit, and then in the Thevenin circuit, find out what is the voltage across that resistor, and then do it for the 6-point K. So you just go back to that circuit. Okay, so you just go back to that circuit and you have to stop any simulation to make a change and just come in here. One of the things I should do is I'm just going to relabel this load. All right, so this is my R load here. But then the R load, then we can, if we want 6.8K, we can put in 6.8K. Now, this is a variable resistor, so you need to kind of vary it the entire way to get that value. And there's a different potentiometer you can select also, whichever one you want to use. But the nice thing about this one is it lets you slide the resistance as you're simulating. Okay, so as long as it's large enough, you don't actually have to stop it. Okay, the only thing is it shows you a percentage, so then you got to figure out, well, if it's a 6.8K potentiometer and it's a 50%, right? Well, then that's 3.4 kiloohms. So you would have to do the math. Now, if you make this a 1K, which is the way the one circuit showed it to be a 1K, and it's in percentages, it's kind of easy. Right, so if you're at 50%, it's 500 ohms. So if you want 470 ohms, you've got to drop down to 47. Which it's not letting me go to 47. Well, let me, so you can either edit them or whatever. So you can make a change while you're in simulation mode, but it won't apply that change until you stop the simulation and restart it. Okay, so we've used the multisim a little bit, at least in the DC, or at least most of you have. Some of you, maybe if you didn't have me for DC, you haven't used multisim, but it's pretty simple to work through. If you have some trouble, let me know. Okay. All right, now the other part is we need to graph our values. Okay, so if you look at the lab, okay, in the lab, when we go to part 2 and part 3, we need to fill out this table. Now, I'm not overly concerned about the table because I would just want to see the plot. So the filling out this table, you should really kind of work through and fill out this table and write down these values. Okay, but what you're going to do here is you're going to use this 0 to 1K pot, which is what I was showing you, and you're going to adjust RL to get the maximum effectively what you're looking for is the maximum voltage, right? So you got over here, maximum power is the voltage divided by the voltage squared divided by the resistance. And again, that 8 pops in because they're saying use the peak-to-peak voltage. Okay. So that's where that comes from. And then you're going to plot, over here you're plotting power versus the capacitive reactance. All right. Now, in the document, let's flip back to the document for a minute. So in the document that I gave you, I give you this chart. It's effectively what you have there. What you want to do here is you want to come over here and cut this chart out of here. Okay, so you want to cut the chart out of there. So notice it's between parts 3 and 4. And then we're going to open up Paint. Hopefully you guys have used Paint at one time or another. I'm going to open up the Paint program. Not Paint 3D, just Paint. And we're going to paste this chart in here. Okay. And so I'm going to paste this chart, and then I'm going to look at my table. In my table I had, I'm just going to pick some values here. So let's say that I had, notice this is kiloohms. All right, so let's just say that I had 1,000 kiloohms, and it gave me like 3 millivolts. So I'm going to come up here, and what you want to do is you want to kind of choose the size, make this kind of large here, so that it shows up. And so at 1K, at 1 kiloohm, I had 3 milliwatts. And so what I'm going to do is I'm just going to draw a little dot there. Okay. And then if you want, once you draw the dot, you can make a copy of it. And then when you plot your next point, it didn't take my dot. Need to draw it again. So I'm going to just come over here. I'm just going to grab this little circle and draw this here. And then click somewhere, and then doesn't seem to be pasting it again. So I'll just draw another one. Okay, but what you want to do, oh, I see what's happening. I'm hitting the wrong button. All right, so what you want to do is you just mark your points here. And just kind of draw these little dots. Okay. And then we want to go to the pencil. Okay, and then with the pencil, we're just going to draw a line through our dots and get a look at the graph. And what we're really looking at, of course, is where is our maximum power? Okay, so so we're kind of looking for this maximum power plot. Okay, but so now once we get that, you want to just come over here, you know, so you got this drawing here. And if you do a Control A, it will select the entire drawing again. And then I'm going to cut that out of there and paste it back into my Word document. Okay, so I'm just going to come back in, and where I had it, I'm just going to paste it back in, but now with the maximum power. Okay, and then we're going to do the same for part 4. Oh. All right, and did part 4 not have the document, or did I delete it? Part 4 should have had a separate graph in there. Let me reopen this document. graph 13.1. Okay. I'm going to re-upload the document. I didn't get the second graph in there. It's slightly different numbers. Okay. All right, so I'll upload that in a little bit. But is there any questions on what we need to do for this lab? Okay. I'm not worried about, I mean, you know, you've done his labs before, you know, he asked 350 questions, okay? All I'm asking for is that you fill out this table. You give me a copy of the original circuit that you did in the multisim. You give me a copy of the Thevenin circuit you did in multisim. And you give me the graph 13.1. Showing me the maximum power. Okay, and I don't much care about the arrow, but I want to see the plots of your values. And then the maximum power for part 4, which is graph 13.2, which I will upload that. I'll re-upload that document with that. I guess I forgot to add it in there last night. Okay. All right, so that is what you need to do for the lab. Any questions there? Yes, exactly, Alex. What I'm asking for you to do is basically go through the lab. We're going to skip part 2, but go through part 1 and part 3 and part 4 and go through it using the multisim. Okay. And so using the multisim, and what you're going to have to do is just every time you need to change a value, you know, if you need to change a resistance, or you need to change a voltage or something, you just stop the simulation, change it, and, you know, make it some other value, and then rerun the simulation. All right. So in your case, you're going to be changing capacitances and resistances. Okay. And then just read these values right off of this probe. Okay. All right. And so, and to your question, Hunter, yeah, I'm all I'm looking for in this document are these values in this Word document here. Okay, I'm looking for these values. Now, these values, I do want to see the 3 significant digits and the units. Like I say, you can just type out degrees if you want, but whatever voltage. And for ohms down here, you know, you can put ohms plus J. Something like that. Okay. But I'm just looking for the, you know, so I want to see 3 significant digits. So if it's 470, there should be a period there. And 445, you should probably put the period there also, but definitely with 470 because of the 0. And just put those values in there, put those circuits in there. I only need to see just kind of one copy of the circuit and then the 2 graphs. Okay. And I don't care whether they're real accurate. If you get something that kind of looks like this, okay, and you know, it looks like your numbers are kind of where they should be, then you're going to get full credit for the lab. Okay. All right. So I'm going to stay online here. I'm going to stop recording, but I'm going to stay online. So if you guys are having troubles, and we might have to switch to maybe a